Okay, hello. I had this idea yesterday, and I have these ideas all the time around state management and stuff. And for me, it's kind of like exercising when I get these ideas, because then I play around with API surfaces, think about different approaches, because we have these two worlds of immutability and mutation tracking now, which differs a lot on the API surface. Like, I just want to think about this and iterate on this, and I also really want to help people using Redux, because especially with TypeScript, it's just so much stuff you have to implement and write and configure and set up. And as you keep implementing, you have to repeat this process, and it's no fun. Like, it's not fun to work with Redux, because you have to do so much just stuff you have to do that doesn't really help you, which could be a lot easier if the API surface was different. So the thing with Redux is that you have this reducer, and a reducer is a good thing because you isolate the types of changes you can do to your state. So you don't allow any kind of change to the state by default. You have to be explicit about naming a type of action, and this type of action represents a type of change to the state. And also with these reducers, you have a tendency to put these into namespaces, but so you have like multiple state values inside one reducer. What's kind of funny in my experience is that you rarely do something to multiple state values. When you receive an action does a specific change to a specific value. And the reducers are more like namespaces. It's just to hold more state. So, and if you were to do multiple like changes to multiple state values, you can still do that by firing multiple actions. So with that premise, I started thinking about a different approach to define the state and how you make changes to it. So you still have the restriction. So I just have a sandbox here with a component. Nothing special. I also have like the use selector and use dispatch thing where I've typed it with the type of for this application, because that's also something I really care about, is creating APIs that are really good for typing. So you don't have to throw types everywhere. You kind of just get it out of the box. Okay, so let's see how this works. I have a store here, so you do this like create store just like Redux, but instead of passing in a reducer, you pass in a tree. Now Redux is a tree. It's just built up by reducers. While here we are creating nodes instead. I'm just calling it nodes. So how would such a node look like? Well, let's create something simple like foo. So I insert a node and I'll give it the value bar. And as we can see here, we have foo bar. Okay, but I can't make any changes to this yet. Maybe we can just put it into the component first. And here you see how you define the types for the state and the dispatch. You actually just say type of tree on both of them. And then you get the dispatchers and the state. So let's do const foo, and we're going to use selector, and this knows about my state now. So I have foo there, and then we're going to use the dispatcher as well. So let's put it in here, foo. Let's see, hello bar. There it is. So how would we make a change to this? Well, the second argument here are the different actions you can perform on this node. So I would do a set here, which takes a function, and the first argument is the value itself, and the other arguments are whatever you want to have as a payload. So we just want to set a new value here, which is of type string, and that is what we're going to return. So what you return here is the new value, and you're responsible for making this value a new value. In terms of arrays and objects and stuff, this needs to be a new value. This is what ensures like immutability. Anyways, so let's have a look now at our code here, and let's implement an onClick. So when we click this thingy, we are going to dispatch, and the dispatch is allows you to dispatch actions. But with this library experiment thing here, you will get some additional properties. So you will actually get the state structure on the dispatch. So we say foo, and then we have a set, and it says that new value should be of type string. When we say that, we click it, we can see that it changes. So let's look at the DevTools. What it gives the DevTool is the path to the value, and then with the double @ signs, like which is like a convention in Redux, we give it a method that we used. And then the payload is an array because there can be multiple arguments, and you see the value, which is really nice. Yes. So the thing about this node thing is that it's actually quite low level. So the point is that it's like a building block. So instead of using node, I have this file called nodes here. So let's import value from nodes instead. And then we'll just say value bar. And let's have a look now at the set. And it still says set new value string, which should be a string. And that is because I have a string here, so it infers that it should be a string. But I could be explicit about this. I could say that it should be a number, for example, and so on. And yeah, this works exactly the same. And that is because if we look at the implementation, it is the exact same implementation. It's a function that takes a value and it returns a node with that value with a set method. And that means that whenever you just want like a plain value, you can just add it as a value, and then you will get the set method to change it. Yes, but then we can use this same building block to create more complex types, node types. So for example, here we have a dictionary. So that would be expressed something like items. Let's import it. Dictionary. And I want this to be a dictionary of strings. And it's empty. So if we take a look at the dispatcher now, now we have items, and we can add an item where we get the key, and the item should be a string. So I haven't really tested it, but let's try it. Foo bar. Yes, and then let's see what happens if I click it. So we have a payload with foo bar, and what we can see here, yeah, we have items with foo bar. And in this implementation, we make sure that we actually change this correctly. So instead of making sure, like a lot of stuff we do is very mutation-like. Like we don't have, for example, a list of to-dos. It's just an array, and we just want to add stuff to it and remove stuff from it, for example. And we don't really, and we could even do things like manipulate a single element, for example. But the point is that we have to redefine this stuff all the time. But with this node value concept, it's possible to create these generic concepts for handling like normal state. And whenever you have something that needs to be limited or has some special functionality or something, you can create a new node type, just like we see here. So again, we have like list where we add by concatenating, we remove by, oops, so this should be slice 0. And then we splice it, blah, blah, blah. And what we could do here as well, we could say like change item, for example, if that is something we want to do. We want to update the item inside that list. No matter, the point is that this is like a core simple API, which you can extend upon, and then you will build your state tree using these nodes. And if you were going to use namespaces and stuff, you would just create like a namespace, like a part of the tree where you have your nodes, and then you would do something like namespace A and then namespace B, whatever, it doesn't matter. But yeah, I think this concept of a tree and a node allows you, especially with TypeScript, define that state tree in a much simpler way, because you do get the typing for free, basically. And also using the dispatcher, like you don't have to create any action types or anything. You just get the dispatcher with these methods for manipulating that part of the state tree. Yes. I don't know if that got you excited or not. For me, this was, again, it's just an experiment. But like if I were to look at this and then look at the reducer, I would definitely try this first, because it's just way less typing and stuff. It's less complex, I would say, but you get the same benefits in terms of you are explicitly defining how you are able to change your state. And here I haven't added like freezing of the values and stuff, but that would of course be possible to do. But yeah, I just wanted to share it. I hope you liked it. Let me know if you want to code for it and want to play around with it. I can put the link in the description. But anyways, just a fun experiment I want to share. Have a great week. Talk to you later.